Launched from Japan on February 27, 2014, the NASA-JAXA Global Precipitation Measurement Mission, or GPM, has changed the way we see precipitation. It has provided unprecedented three-dimensional views of everything from light rain to intense thunderstorms. To mark its 5 years, we're looking back at 5 big moments in GPM's history of observing storms. Not long after its launch in 2014, the GPM core satellite captured Super Typhoon Vongfong as it headed for Japan.
Super Typhoon Vongfong was one of the first Category 5 intensity cyclones that GPM was able to observe.
The radar data revealed a clear eye wall with bands of rain encircling it, forming a secondary eye wall. GPM was able to observe Vongfong as it weakened.
So the reason that Vongfong was weakening at this time is what we refer to as an eye wall replacement cycle. So those bands outside of the eye wall forming a circle, they essentially cut off the inflow to the storm.
Hurricane Harvey slammed into Texas and Louisiana in August 2017, dumping feet of rain, making it the wettest tropical cyclone on record in the United States. GPM was able to see the full structure of the hurricane beyond the reach of ground-based radars.
As Harvey perched over Houston, it became highly asymmetric, with a large area of rainfall to the north and almost no rainfall to the south.
The GPM mission was able to observe the historic rainfall estimates over land and ocean, shedding light on the structure and magnitude of the storm's impacts. Later in the 2017 Atlantic hurricane season, GPM was able to see the evolution of Hurricane Ophelia.
What was interesting about Ophelia was the fact that it formed sort of from a decaying extratropical frontal system, what we call tropical transition, going from an extratropical system to a tropical one. It managed to intensify up to a Category 3 hurricane in the eastern Atlantic. And this is the farthest east that we've had a storm of that intensity in the satellite record.
Later, Ophelia raced off to the northeast, bringing severe winds to the United Kingdom and Ireland. On January 4, 2018, a large snowstorm rapidly intensified as it moved from the southeastern US up the east coast.
In fact, it intensified so rapidly in terms of the drop of pressure at the center, it was called a bomb cyclone, and intensified about as much as you'd see with an intense hurricane.
GPM clearly depicted the transition from rain to snow, shown here as the rain layer in green, yellow and red becomes shallower and thinner as it progresses northward into snow, shown in blue. The GPM mission joins together data from an international network of satellites to create a global picture of precipitation in the Integrated Multi-Satellite Retrievals for GPM, or IMERGE for short.
The great thing about IMERGE is that the fine scale in space and time allows you to really see the details, and they flow smoothly from one image to the next. When you look at this particular week of IMERGE, you see some very general patterns. You see the high precipitation in the tropics, lower precipitation to the north and south of that, and then the storm tracks in mid-latitudes.
For 5 years, GPM data has advanced our understanding of how hurricanes form and intensify, demonstrated how individual raindrops are distributed inside storms, and produced unparalleled global coverage of precipitation across land and sea.